Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 4 from Module 2. Interpreting and computing division of a fraction by a fraction, more models. So the classwork opening exercise says to write at least 3 equivalent fractions for each fraction below. So try these, pause the video, then come back and see if any of yours match mine. And if they don't, it does not mean they are not correct because there are infinitely many solutions. So go. Okay, so one way we could do this is just multiply the top and bottom by 2 and get 4 over 6, or multiply 2/3 times 3 over 3 and get 6 over 9, or multiply 2 over 3 times 4 over 4 and get 8/12, because anything divided by itself is 1. So really I'm just multiplying by 1 every time. So these are just scale multiples of the same thing. An easier way to do that is just to add a 0. So if I multiply by 10, I get 20 out of 30. If I multiply by 100, I get 200 over 300. So I'm just adding on 1 0 at a time. And I can do this infinitely many times. So there's several examples there. Okay, so the next one, 10/12. So if I show my work, I'm going to write 2 over 2. 10 times 2 is 20. 12 times 2 is 24. So 10/12 is equivalent to 20/24. And then we'll do a couple more here. I'll multiply by 3. And 10 times 3 is 30. And 12 times 3 is 36. Or I could just simply add a 0. 10 times 10 is 100. 12 times 10 is 120, and so on and so on. So there's just a few examples of equivalent fractions. Okay, and these are the 3 that were equivalent to 10/12. Okay, so like I said, they may match, they may not, but it does not mean you are not correct, as long as they are multiples of the original. So now we'll move on to example 1. And here it says, Molly has 1 3/8 cups of strawberries. She needs 3/8 cups of strawberries to make 1 batch of muffins. How many batches can Molly make? Use a model to support your answer. Okay, so the first thing I see here is we have a mixed fraction. So the first thing I want to do is convert this to an improper fraction, or a fraction all by itself that is greater than 1. So in order to do that, I'm just going to show all the work. 1 3/8 equals the denominator, 8, times the number out in front, the integer, 1, and then I add the numerator in. And I divide all of that by my original denominator. So in order to do this, I say, okay, 8 times 1 is 8. 8 plus 3 is 11, and over 8. So 11/8 is the same as 1 3/8. So the first thing you had to do is convert that into an improper fraction. And if we want to know how many 3/8 are in 11/8 or 1 3/8, then we take that 11/8 and we divide by 3/8 to get our answer. And there's a couple of different ways to do this, and since we've done these already, I will show you both ways. We can flip it and switch it, as we say in class. In other words, we can't divide a fraction by a fraction, but what we can do is take the original fraction, 11/8, and instead of dividing, we can multiply by the reciprocal, 8/3. So when I say flip it and switch it, I'm saying flip the fraction over and switch the sign from division to multiplication. And when I do that, now I have an 8 in the numerator and an 8 in the denominator, so they cancel, and my answer is 11/3. And if I want to make that mix, 3 goes into 11 3 times with a remainder of 2. So it's 3 2/3. Okay, the other way I could explain that is, let's go back to this here and I'll rewrite it. 11/8 divided by 3/8. Whenever we're dividing a fraction by a fraction and the denominators are the same, we can ignore them and just do what the expression says above, 11 divided by 3. Well, that's what I have right here, 11 divided by 3. So that is also going to be 11/3, which is 3 2/3. So those are two different ways we can convert, but they have to have the same denominator to do this shortcut. Okay, so now it says to use a model to support your answer. Okay, so in order to do a model on this, we want to look at our denominators. So let's focus on this circled red here. We have 11 over 8 divided by 3 over 8. The denominators are the same, they're both 8. So if I make a tape diagram and try to make this as even as possible, if this is one square and they're all the same, I need 8 of them. So I'd go out to there. So there's my tape diagram. There's 8. Okay, so but, and there's a but here, 11 is more than 8. So this is 1. 1, 2, 3, 4, 5, 6, 7, 8. If each one of these is 1/8, then this is 8/8 or 1. Well, I need 3 more. Okay, so I need 3 more. Let me just do this. Let me change colors. So I need 3 more. So I need to continue this out. And there's 1, there's 2, there's 3. And since I went out, I want to see what a whole looks like. So I'm going to go out to the whole 2. So there's 3, and I'm going to go out to another 8/8. So there's 3, here's 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is 16/8 or 2. So we're taking 11/8. So here's 8/8 and 9, 10, 11 would get us out to here. So 11/8 is all of these. That is 11/8 or 1 3/8. This is 1, and then this is 1, 2, 3 more. 1 3/8 or 11/8. So I'll write both. Okay. Now what this means is how many 3/8 are in 11/8. So I'm going to group these in threes. So that's 3/8. This is 3/8, 3 of them. I need another 3. Takes me out to here. Okay, but if you see the color changed here, I have 1, 2, and 2/3 of a 3/8 in 1 3/8. And so the answer is 2, and I have a 3 here. That should not be 3. 3 times 3 is 9 plus 2 is 11. That is correct. Okay, so this is 9/8, so it's more than the 1, but we want to know how many 3/8 are in 11/8, 1 3/8. So I need to keep going here. And there's another one, and that is 3/8. So there's an extra 1/8 hanging out over here. So 1, 2, 3. There's one group of 3/8, and there's 3. That's 2, 3. And then on the fourth one, we only have 2 out of 3 of them. So it's 1, 2, 3. And this is only 2/3 of that last section of 3/8. So the answer is 3 2/3. Now, before I move on to the next problem, we need to take this and put it into context of the real world situation that they're talking about. Molly has 1 3/8 cups of strawberries. She needs 3/8 cups of strawberries to make one batch. How many batches can Molly make? Well, I don't think anybody is ever going to make 2/3 of a batch of something. So the actual answer the answer to this would be 3 batches. And she's going to have leftover, I can't spell tonight, 3 batches. Okay, she can make 3 batches, but she's going to have ingredients left over because there's enough for 2/3 more of a batch, but she'll probably stop at 3 batches. Okay, so now let's move on to the next problem. And example 2 says, Molly's friend Xavier also has 11/8 of a cup of strawberries. He needs 3/4 of a cup of strawberries to make a batch of tarts. How many batches can he make? Draw a model to support your solution. So this one we did not have to convert. It was already improper. And we're dividing. We want to know how many 3/4 are in 11/8. So we're taking 11/8 divided by 3/4. And that is the same as saying 11/8. times the reciprocal of 3/4, which is 4/3. So flip it and switch it. Okay, so I always say to reduce first if possible. Make the numbers smaller before you make them bigger so it's easier to deal with. So 4 will go into 8 twice. Now this is a 1. 4 goes into 1, or 4 goes into 4 once. So now I have 11 times 1 is 11. 2 times 3 is 6. And I don't want a improper, so 6 goes into 11 one time with a remainder of 5. So the answer to this question is, how many batches of tarts can he make? Well, he's not going to make 1 in 5, 6 batches. He can make 1 batch of tarts. Excuse me. Okay, so now it says use a model to support your solution. Okay, so it's going to be the same thing here. So one moment. Okay, so I brought in the same tape that I used in the last problem just to save time to build this. And remember, these are all worth 1/8 apiece, every single one of them. So there's a total of 2. This is 2 and this is 1. 8/8 and 8/8 is 16/8 or 2. And the question says, how many 3/4 are in 11/8? Well, 11/8, 8/8 is here, 9/8 is here, 10/8 is here, and 11/8 again is in the same place as it was on the last problem. This is 11/8. And we want to know how many 3/8. Okay, so let me just move this all down a little bit. Okay, so now I want to know how many 3/4 are in this 11/8 span. So 3/4 is 6/8. So first of all, we need to get this into 8 since we're talking about 8s. 3/4 times 2 over 2 equals 6 over 8, just like we did in the beginning. That's why we did this. So I need 6/8 to be 3/4. So there's 1, 2, 3, 4, 5, 6. So right to here is 6/8. Okay, so let me move this math out of the way. I just want to show you what I was doing. So this is 3/4 or 6/8. So if I go 1, 2, 3, 4, 5, 6, where did it go? 1, 2, 3, 4, 5, 6. It's actually out. One more. Here's 1, 2, 3, 4, 5, 6 goes to here. This is 3/4. So this is 1 whole 3/4, and then 1, 2, 3, 4, 5 of 6 squares that make this 3/4. So the answer is 1 and 1, 2, 3, 4, 5 out of the 6 that's not in it. So that's 1 and 5/6, which is what we got here. So we can make 1 batch of tarts. Example 4. Find the quotient of 3/4 divided by 2/3. Use a model to show your answer. So here they're telling us to use a model to show our answer rather than doing the math first. So I have a 4 and I have a 3. Okay, I got ahead of myself there. I skipped example 3, so I backed up. So we have 6/8 divided by 2/8. So our denominators are the same. So I'm going to draw a tape diagram with 8 squares. So here's 1, 2, 3, 4, 5, 6, 7, 8. I could make this neater, but I just didn't want to take the time in the video. I could use a straight edge ruler and make all these really nice, and you should do that on your paper. Okay, so we have this. So what the question is, it says how many 2/8 are in 6/8? Find the quotient 6/8 divided by 2/8. So here are 6/8. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 squares. Okay, so if we take 6 of these 8s, that would be right here. There are 6. These are all 1/8, remember. And I'll write these in this time. Maybe this will help. So we have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8 is right here, or 3/4. So the question's asking how many 2/8 are in 6/8. Well, 2/8 is right here, so there's 1. Here's another 2/8, so that's 2. And here's another 2/8, and that's 3. So the answer is 3. So 6/8 divided by 2/8 equals 3. That was using the model. Now, to do this mathematically, I would just take that 6/8 divided by 2/8, switch it to multiplication. Actually, no, I would not. I would see that my denominators are equal, and I would use my new shortcut and get rid of the denominator. 6 divided by 2 equals 3. Okay, and now let's go to example 4. It says find the quotient 3/4 divided by 2/3. Okay, in this example, example 4, I drew a really nice, neat tape diagram. It took me a little while, so I did it off screen, and here we go. And I used 12 squares because I look at my denominators. They're not the same. 4 times 3 is 12, so I'm splitting these up into twelfths. So this is 1/12, and they're all twelfths. So I'm going to write these all in like this, and they'll be here when you come back. Okay, so 1/12 through 12/12. So what I'm saying is if we have 3/4 and we multiply it by 3/3, like the first exercise did, 3 times 3 is 9, 4 times 3 is 12. So what are we talking about here? We're talking about 9/12. So that is everything out to there. So that is my 3/4. 3/4 of this tape diagram goes out to here. And they want us to divide it into 2/3. Well, if I come over here now and do 2/3, and I want to get it into twelfths, then I need to multiply 3 times 4 to get 12. So I'm going to multiply by 4/4, and 2 times 4 is 8. So really what we're doing is, if I convert 3/4 to 9/12 and 2/3 to 8/12, I can now rewrite this problem as 9/12 divided by 8/12. And remember the rule. If our denominators are the same, ignore them, and it's just going to become 9 divided by 8, which is 9/8, or 1 1/8. Okay, well, we don't have eighths here, but if we think of it this way, and 8/12 is right here. 8/12 is right here. Why am I going to 8/12? Because that's our 3/4. 8/12 is 3/4. But we're taking 3/4 and we converted it to 9/12. Well, 9/12 is 3/4, my fault. What I'm trying to say is 8/12 is, what I have done is converted this. So if this is out to here, 8/12 is my 2/3. So there's my 1 right here. So think of the distance from here over to here as 8/8, or 1. And then I still need an eighth to get my answer. Well, if these are eighths, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, my answer was 9/12 or 3/4. And I'm now saying that if these are eighths, because my answer is 9/8, I can break this down into eighths. And so this is 8/8, and then this remainder is 1/8, and that gives me 1 1/8. Now, you might think it looks like 9/8 equals 9/12, but what we're really doing is just converting our 3/4 into 9/12. This is 3/4 of this whole thing. We aren't using these 3, and that's why that is 9/8 of this. Okay? So this is 8/12 of the whole tape diagram, but this is 8/8, and this is 9/8 of the amount we're interested in. So these 3 values over here are not part of our problem. So my answer is 1 1/8. Okay, exercise 1 through 5 says to find each quotient. So I am just going to do this without a tape diagram. So I'm just going to take 6 divided by 2 and multiply by the reciprocal 4 over 3. And then I always cancel first, so 2 becomes 1. 2 will go into 4 twice. 3 will go into 3 once, and 3 will go into 6 twice. So I'm left with 2 times 2 over 1 times 1, which is 1, or simply 4. Another way I could do this, if I want to make this denominator the same, I could multiply this by 2 and get 12 over 4. 2 times 6 is 12, 2 times 2 is 4. 12 fourths equals 6 halves. Divide that by 3 quarters. And now my denominators are the same, ignore them, and divide 12 by 3 and get 4. Okay, so in this one, same thing, 2 over 3, flip it and switch it, 5 over 2. The 2's cancel, and my answer is 5/3. Number 3, 7/8, flip it and switch it, times 2 over 1. The 2 makes the 8 a 4, and that is 7 times 1, which is 7, and 4 times 1, which is 4. And if you don't like improper, 4 goes into 7 once with a remainder of 3. And if I go back up, 3 goes into 5 once with a remainder of 2. Okay, 3/5 divided by 1/4 is 3/5 times 4 over 1, and 4 times 3 is 12. Nothing cancels or reduces here, and 5 times 1 is 5. 5 will go into 12 twice with a remainder of 2, so it's 2/5. And finally, 5/4 divided by 1/3 is 5/4. Flip it and switch it, times 3 over 1. Nothing reduces here. 5 times 3 is 15, and 4 times 1 is 4. 4 goes into 15 3 times, which is 12, with a remainder of 3. 3 3/4. And that is the end of Lesson 4. Go to your problem set.